Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 15 Similarity. We will be studying all the concepts with example and solve many questions from exercise 15A. Hope you all are ready for this session. Let's solve together. Let us first understand what are similar figures or the similarity of figures. Here we can see two squares, two circles and two triangles. How can I call these figures similar? Can I call this square as similar to this circle? Here we have a big square and a small square. A big circle, a small circle. A big triangle and a small triangle. Can I call this big square as similar to big circle? No, right? Because they have different shape. But I can say that this big square is similar to the small square. They have the same shape. So, same shape is the criteria which helped us to tell that these two figures are similar. We cannot say this square is similar to this big circle or this big square is similar to this big triangle. Why? Because they are having different shape. So here the big square is similar to small square. Big circle is similar to small circle. And this big triangle is similar to small triangle. Got it? That is, two shapes are said to be similar if they have the same shape but may differ in size. This is a bigger one. This is a smaller one. But they have the same shape. Yes? Therefore, these two figures are similar. Here again, this is big, this is small. Only thing is, they have the same shape. Since they have the same shape, they are similar. Here again, this is bigger one and this is smaller one. They have the same shape. They are similar figures. Got it? Now, what is congruency of figures? We understood what is similarity of figures. What is congruency? Here, when you compare with the previous slide, we can see that these two squares are of the same size. Yes? They are squares, they are having the same shape, they are also of same size. What about these circles? They are also of same size. And these triangles are also of same size. Yes. So here we need same shape as well as same size. Okay. If we are taking two similar figures, and these similar figures are having same size, then they are congruent figures, or this is what congruency of figures are. Got it? Two figures are said to be congruent if they have the same shape and same size. Similar figures have the same shape but the size can be different. Here when it comes to congruency of figures, they should be of the same shape and of the same size. Let us take another example. Have you heard about identical twins and fraternal twins? Yes, you have heard. So when you take the identical twins, they will be having same color, same height, same width, everything, right? Same hair color, eye color, everything will be same. So in that case, we call them congruent figures. Yes, they are congruent. Everything is same. The shape, size, everything is same. But when you take the fraternal twins, they will be having some similarities. They are not identical. Yes, the size may be different, their eye color may be different, but there are some similarities in them. So they are similar and the identical twins, we take them as the congruent. Got it? We understood what similar figures are. Let's see what similar triangles are. Here I have taken two triangles. Let us name them A, B, C and P, Q, R. Triangle ABC and triangle PQR. Are they similar? Yes, they are similar, right? Because both of these are of same shape. They are triangles. Only differences in their size. They can be called similar figures. Now, there are some criteria on the basis of which we can call them similar figures. Here, the first angle A from triangle ABC should be equal to angle P of triangle PQR. Similarly, angle B of triangle ABC should be equal to angle Q of triangle PQR. Angle B equal to angle Q. Also, this third angle C should be equal to this third angle R. Okay, that is these angles with respect to A, here we have P. We call them corresponding angles. So, corresponding angles should be equal. Okay. One more thing, that is, here we have side AB opposite to angle C. And here we have PQ, side PQ opposite to R. We call this AB and PQ as corresponding sides. Corresponding to AB, here we have PQ. Corresponding to AC, here we have PR. And corresponding to BC, here we have QR. Got it? That is angle. Here we have taken angle A. Opposite to angle A, we have BC. Opposite to P, corresponding to A, angle is P. Opposite to P, we have side QR. So, we call them corresponding sides. Now, when you take the ratio of the corresponding sides, they will be equal. Here, corresponding to AB, we have PQ. AB by PQ will be equal to, corresponding to AC, here we have PR. AC by PR, and that is equal to BC by QR. BC by QR. So, first things, to call two triangles similar, their corresponding angles should be equal and the ratio of their corresponding sides should be equal. Two triangles are said to be similar if their corresponding angles are equal and corresponding sides are proportional. They are in ratio. The ratio of their corresponding sides are equal, which means the corresponding sides are proportional. Understood? When do we call two triangles similar? So, what are corresponding sides? When you take angles, here we have A and here we have P. When you take these angles and take the side opposite to these angles, they are called the corresponding sides. Okay. So, when you take angle A and angle P, with respect to A, we have BC, and with respect to P, we have QR. So, these are the corresponding sides. When you take angle B from here and angle Q from here, we know these two angles are equal if two triangles are similar. Similar triangles, triangle ABC and triangle PQR. We represent similarity using this symbol. Okay. When you use this symbol, it means triangle ABC is similar to triangle PQR. So, when two triangles are similar, we'll be having angles equal, corresponding angles equal. Here A, corresponding to A, we have P. Corresponding to B, we have Q. So, when you take B and Q, the side opposite to B is AC. AC, and side opposite to Q, we have PR. So, AC and PR are the corresponding sides. Now, when I take the third angle C, here we have the third angle R. Okay, we'll be having angle C and angle R equal, sides opposite to C and R. Here we have AB and here we have PQ. Okay. So, AB and PQ are the corresponding sides. So, in case of similar triangles, the sides opposite to equal angles are said to be the corresponding sides. Just what are corresponding sides? Corresponding sides are the sides that are opposite to the corresponding angles or the equal angles of the two similar triangles. Clear? Now, what are corresponding angles? Take the same two triangles ABC and PQR. If these two triangles are similar, triangle ABC similar to triangle PQR, we know that their corresponding sides are proportional. Here, corresponding to AB, we have PQ. Corresponding to BC, we have QR, and corresponding to AC, we have PR. Okay. Now, the ratio of these corresponding sides, AB by PQ, will be equal to BC by QR, and that is equal to AC by PR. Okay. The ratio of the corresponding sides are equal. Now, corresponding to AB. Here, when you consider this ratio, AB by PQ. Okay. What is the angle opposite to AB? Opposite to AB, we have the angle C. Angle C. And opposite to PQ. Here we have PQ. Opposite to PQ, we have R. So, these two angles will be equal. Clear? When you take BC, this ratio, BC by QR. Opposite to BC, we have A here, angle A. And opposite to QR, we have P here, angle P. A will be equal to angle P. Now, the third ratio, AC by PR. AC, here we have AC, opposite to AC, we have angle B. Angle B, and here opposite to PR, we have angle Q. Angle B will be equal to angle Q. Okay. So, in similar triangles, the angles opposite to proportional sides are the corresponding angles, and so they are equal. So, you understood what corresponding angles is, and these corresponding angles are always equal. That is just the reverse thing we have discussed when we said about the corresponding sides. There we know the angles, sides opposite to the angles. Here we know the sides and the angles opposite to these sides are equal. Okay, to show that two triangles are similar, we will be using some conditions for similarity of two triangles. We have three postulates to discuss, and the first is the SAS postulate. Let's see what SAS postulate is. Here, I am taking two triangles ABC and triangle DEF. Okay, here let the angle B equal to some 60 degree and angle E equal to 60 degree. Okay, that is angle B is equal to angle E. Okay. Now, AB, this is one side and BC is another side of triangle ABC. When I take the ratio AB by BC, and from this triangle I am taking DE and EF. Let us put some values. Here I am taking 2. Let AB is equal to 2 and BC is equal to 3. DE is equal to 4 and EF is equal to some 6. Okay. When I take the ratio AB by BC, I get 2 divided by 3. AB is 2 and BC is 3. If I take the ratio DE by EF, what do I get? 4 by 6, and that is equal to 2 by 3. Okay. So, when I take these two triangles, we have one angle equal. Here angle B is equal to angle E, and the ratio of corresponding sides. Two sides we have considered. Here when you consider AB and BC, corresponding we have DE and EF. The ratio of their corresponding sides, here we got 2 by 3. Here also we got 2 by 3. In that case, we use the SAS property. To remember, if you are considering this angle, we have to take the sides which touch this angle. That is, the angle should come in the middle. Yes, here AB and BC, the angle 60 degree, that is angle B is coming in the middle of AB and BC. Similarly here, when you take this 60 degree, that is angle E, DE and EF, the sides we have taken DE and EF, and the angle lies between these two sides. Okay, that is the angle should touch, the left side of the angle should touch one side and the right side of the angle should touch the other side. Only then we can call this the corresponding sides which we are taking here. Okay, so the ratio of the corresponding sides, two sides, and the angle which lies between these two sides, if the angles are equal and the ratio of the corresponding sides are equal, we can say that by SAS property, these two triangles are similar. Okay. If one angle of a triangle is equal to any angle of the other triangle, and in both the triangles, the sides including the equal angles are in proportion, then the triangles are similar. Understood the first criteria? SAS postulate. This is SAS postulate. We have to remember one thing. You cannot choose this angle and these two sides. Okay, then you cannot use the SAS postulate. You can only use the angle that lies between the two sides. Clear? Second is the SSS postulate. S for side, side, side. Which means all the three sides should be in proportion with the sides of the other triangle. Here I am taking triangle ABC of sides 2 cm, 3 cm and 4 cm. My bigger triangle, which is similar to ABC, is of length 4 cm, 6 cm and 8 cm. If these two triangles are similar, in that case, the ratio of their sides should be equal. Or if the ratio of their sides are equal, ratio of their corresponding sides are equal, then these two triangles are similar. Okay. So this is what using SSS criteria we can prove. Now, first take AB from the triangle ABC and DE from triangle DEF. What is the ratio? AB by DE is equal to 2 divided by 4 and that is equal to 1 by 2. Okay. Here we have BC, here we have EF. What is the ratio? BC by EF is equal to 3 by 6 and that is again equal to 1 by 2. Third, AC and DF. AC by DF is equal to 4 by 8 and that is also equal to 1 by 2. So when you take two triangles and take the ratio of corresponding sides, if you are getting them equal, in that case these two triangles are similar. This is what side, side, side or the SSS postulate is. We just need to take the ratio of the corresponding sides. We are not considering any angles here. In the previous postulate, what we have taken? The ratio of two sides we have taken and the angle which lies between these two sides. Here in this case, we are not considering any angles, only the three sides we are considering. Clear? So, if two triangles have their three pairs of corresponding sides proportional, then the triangles are similar. Okay. So, this is the second postulate to show two triangles are similar. Now, the third AA or AAA postulate. AA means angle. When it is AAA, same thing, angle. So, if two angles of a triangle are equal, we know that the third angle will also be equal. Because according to the angle sum properties, sum of interior angles of a triangle will be equal to 180 degree. So, if two angles are equal, then 180 minus the sum of these two angles will be equal. Yes, that value will be equal, which means the third angle is also equal. Now, let us consider these two triangles ABC and DEF. Here, angle A is 60 degree, angle B is 55 degree and angle C is 65 degree. Okay. Here again, angle D is 60 degree. Angle E is 55 degree and angle F is 65 degree. In that case, we have angle A is equal to angle D, angle B is equal to angle E. That is, we are getting two angles equal. If two angles are equal, we surely know that the third angle will also be equal. We don't need to write it separately. So, if two angles are equal, then using the AA postulate, we can say that these two triangles are similar. Here we are not considering any sides. We don't need the length of any sides, just two angles. If two angles are equal, then using the AA postulate, we don't consider it as AAA because if two angles are equal, then the third will surely be equal. So we don't need to consider it. So using the AA postulate, we can say that these two triangles are similar. If two triangles have at least two pairs of corresponding angles equal, the triangles are similar. Understood? At least two pairs. What does it mean? At least two, which means more than two is possible. That is third angle, if it is equal or unequal, doesn't matter. But for triangles, you know that the third angle will surely be equal if two angles are equal according to the angle sum property. Okay, so we studied the three important postulate. SAS postulate where two sides and the angle that lies between these two sides is considered. Second, we took the SSS postulate where only the three sides, the ratio of the corresponding sides are taken. And the third, we are just considering the angles. If two angles are equal for two triangles, then they are similar. There the corresponding angles are equal, then the triangles are similar. Let us take an example. In the given figure, triangle ABC is similar to triangle DEF. AB is equal to x minus 0.5 cm, AC is equal to 1.5 x cm, DE is equal to 9 cm and DF is equal to 3x cm. Find the length of AB and DF. Here you can see two triangles, triangle ABC and triangle DEF. Given AB is equal to x minus 0.5 cm. This is AB, x minus 0.5 centimeter. Then AC is equal to 1.5x centimeter. AC, this is AC and AC is equal to 1.5x centimeter. What else? DE is given. DE is equal to 9 centimeter and DF is given. DF is equal to 3x centimeter. Now we need to find the length of AB and the length of DF. Okay, given that these two triangles are similar, that is triangle ABC similar to triangle DEF. For similar triangles, we have the ratio of the corresponding sides will be equal or corresponding sides are proportional. We will be having AB by DE is equal to, here we have BC and here we have EF. This is BC and this is EF. They are the corresponding sides. BC by EF will be equal to AC and DF. This is AC and this is DF. They will be taken in a ratio, that is AC divided by DF. Okay, here we know AB. AB is x minus 0.5. What about DE? DE is given, which is 9. Then AC. AC is equal to 1.5x. DF. DF is 3x. So you can neglect this part and take only these two ratios. AB by DE is equal to AC by DF. Now put the values. We have AB is equal to x minus 0.5 divided by DE. DE is given, that is 9. DE is 9 and that is equal to AC 1.5x divided by DF is 3x. So here we can cancel this x and this x. Okay. Now cross multiplying. What do we get? We are cross multiplying. X minus 0.5 is equal to 1.5 into 9 divided by 3. Okay. This 3 and 9 can be cancelled. We get 3 into 3 is 9. X minus 0.5 is equal to 1.5 into 3, which is 4.5. Therefore, we have x is equal to, taking this minus 0.5 to the right hand side, 4.5 plus 0.5. And that is x is equal to 4.5 plus 0.5 is 5 centimeter. Okay. So 5 centimeter is the value of x. Now how to find AB? AB is equal to x minus 0.5. We have to subtract 0.5 from the value x. That is 5 minus 0.5 and that is equal to 5 minus 0.5 is 4.5. 4.5 centimeter is length of AB. Then we need to find DF. DF is equal to 3 times x. 3 into x, which is 3 into value of x is 5. 3 into 5, 15 centimeter. This is how we can find the length AB and DF. Here we have used 4 similar triangles. The ratio of their corresponding sides will be equal, from which we have found the values of AB and DF. Let us take another example. A perpendicular drawn from the vertex of a right angle triangle divides the triangle into 2 triangles similar to each other and also to the original triangle. Prove it. Okay. Let's consider a right angle triangle. So this is a right angle triangle with right angle at A. Okay. Now I am drawing a perpendicular AD starting from this right angle A to the hypotenuse BC at point D. We have to prove these 2 triangles are similar, that is triangle DBA similar to triangle DCA similar to the original triangle ABC. Triangle ABC. Okay, let's start the proof. So first let us consider the big triangle and this small portion. That is triangle DBA and triangle ABC. When you take these 2 triangles, here we have a 90 degree. Yes, divides the triangle into 2 equal triangles similar to each other. Yes, okay. Here these 2 triangles, it is given that they are equal triangles. We have to prove that. Now when you consider this triangle ABC and DBA, we have angle ADB is equal to angle BAC. Here we have a right angle and this is also a right angle. Both these angles are 90 degree, which means these angles are equal. Okay, we have a common angle here. Angle B is common to both ABC and DBA. Angle DBA is equal to angle ABC. What is the reason? Common angle. Common angle. Both these are 90 degree. Therefore, these 2 angles are equal. Now, what we have? According to the AA postulate or AAA postulate, if 2 angles are equal, then the third angle will also be equal. Using this AA postulate, we have proved that triangle DBA is similar to triangle ABC. Okay, that is the small portion of triangle is similar to the bigger triangle ABC. Similarly, we are going to show the other part, that is DCA. In triangle DCA and the bigger triangle ABC, what are common? There is a common angle here. Angle C is common to both these triangles. That is angle DCA. DCA is equal to angle ACB. ACB. What is the reason? Common angle. Common angle. Then what else? Here this angle will be 90 degree. Already in triangle ABC we have right angle at A, which means angle CAB is equal to angle CDA. Okay, both are right angles or 90 degree. So again using AA postulate. Using the AA postulate, we have triangle DCA similar to triangle ABC. So this is what our proof is. We had to prove triangle DBA similar to triangle DCA similar to triangle ABC. We have got triangle DBA similar to triangle ABC and triangle DCA similar to triangle ABC. That is triangle DBA similar triangle DCA similar to the bigger triangle or the original triangle ABC. Hence proved. Clear? We have taken the bigger triangle and the small triangle first, then the bigger triangle and the small triangle, and after which we concluded that all these triangles are similar to each other. Got it? Let us now solve questions from exercise 15A. Here we have the first problem. Question 1 of exercise 15A. In the figure given below, straight lines AB and CD intersect at point P. Here we have the first straight line AB and CD. They intersect at point P. And also given that AC is parallel to BD. This is AC and this is BD. They are parallel lines. We have to prove that triangle APC and triangle BPD. This is BPD. They are similar. We have to prove these two triangles are similar. And the second part of the question, some values are given. If BD is equal to 2.4 centimeter, BD, this is 2.4 centimeter. Then AC is equal to 3.6 centimeter. AC is 3.6 centimeter. PD is 4 centimeter. And PB is 3.2 centimeter. PB is 3.2 centimeter. We have to find the lengths of PA. This is PA and PC. To find the length of PA and PC. Okay. First, let us show that these two triangles are similar. First part, consider triangle APC and triangle BPD. For triangle to be similar, we have some criteria. We have studied some postulates. Yes, either it should obey the AA congruency. Either it should obey the AA or AAA postulate or the SAS postulate or the SSS postulate. Now let us check for these two triangles. Here, when you consider these two triangles, we have these angles equal. Why? Here we are given that AB intersects line CD at a point P. When they intersect, the angles, vertically opposite angles will be equal. Therefore, we can write angle APC is equal to angle BPD. Vertically opposite angles. Vertically opposite angles. Then what else? Here given that AC is parallel to BD. Now when you consider this CD, this is a transversal, okay, which cuts AC and BD. When a transversal cuts, these two angles are called the alternate interior angles. Alternate interior angles will be equal. When parallel lines are considered, we have corresponding angles equal, alternate interior angles equal. These angles ACP and BDP are alternate interior angles. Angle ACP is equal to angle BPD. Alternate interior angles. Okay. So for these two triangles, we got two angles equal. If two angles are equal for two triangles, then the third angle also should be equal, because we know that according to the angle sum property, the total sum should be equal to 180 degree. From that property, this third angle, this angle also will be equal to this angle. It is not necessary we have to show these angles are equal, because AA is enough. So according to the AA postulate, we have proved that triangle APC similar triangle BPD. Clear? Now the second part of the question. From the first part, we have triangle APC similar triangle BPD. For similar triangles, we have the ratio of the corresponding sides equal. Yes, that is AP, BP. AP by BP is equal to, corresponding to PC. Here we have PC, we have PD. Okay, PC by PD. You have to check this order. When you are taking PC, you will be taking PD as the corresponding side. Equal to AC, BD. AC by BD. AC by BD. What do we need to find? We have to find the length of AP. Where do we have AP? This is AP. Do we know BP? Length of BP. Yes, we know the length of BP. Now, if I take PC, PC is a value which is unknown. So, two unknown values cannot be equated to find. Therefore, if I take AC by BD, AC is this length and BD is this length. Both of them are known values. Therefore, we will be taking AP by BP is equal to AC by BD. Put the values AP. We don't know what AP is. Keep it as it is. Then BP. What about BP? Here we have BP equal to 3.2 centimeter is equal to AC by BD. AC is 3.6 and BD is 2.4. Which implies AP is equal to 3.6 by 2.4. I am taking this 3.2 to the opposite side into 3.2. Okay. Here 2.4 and 3.2 can be cancelled. 0.8 into 3 is 2.4. 0.8 into 4 is 3.2. So here I get 4. Now 3.6 by 3. What do we get? 1.2. 1.2 into 4. What is 1.2 into 4? AP is equal to 1.2 into 4 is 4.8. 4.8 centimeter. We got AP equal to 4.8 centimeter. What else we need to find? We have to find the length of PC. PA and AP are same. Okay. PC. This is PC. Yes. Here we have PC. So, we will be considering these two. These two ratios we are considering. PC by PD is equal to AC by BD. Put the values. We have to find PC is equal to AC. AC we have. AC is 3.6 divided by BD. We have BD. Value of BD is 2.4. And here in the denominator PD, the value of PD is 4 centimeter. Which means PC is equal to 3.6 into 4 divided by 2.4. Taking this 4 to the opposite side. Okay. 4 and 2.4 can be cancelled. 4 into 0.6 is 2.4. Here we get 0.6. 3.6 divided by 0.6. That is 36 by 6. Numerator and denominator I am multiplying with 10. 36 by 6. What is the value? We get 6 centimeter. Therefore, the length of PC is 6 centimeter. Clear? First, we are proving these two triangles are similar triangles using the AA postulate. After that, using the corresponding ratio of the corresponding sides, we are finding the lengths of PA and PC. Okay. Now, the second problem, question 2 of exercise 15A. In a trapezium ABCD, side AB is parallel to side DC and the diagonals AC and BD intersect each other at point P. Prove that first triangle APB is similar to triangle CPD and the second PA into PD is equal to PB into PC. Here, let us consider trapezium. This is how a trapezium looks like. Given that side AB is parallel to side DC. These are the parallel sides of trapezium. Okay. Also, it is given that the diagonal AC, from this corner to this corner, we have the first diagonal and the second diagonal BD. This is BD. From this corner to this corner. They intersect at a point P. This is the intersecting point P. We have to prove that APB, this is APB, triangle APB And this is triangle CPD. We have to prove they are similar. Let's see how to prove this. Okay. The first question. Here when you consider these two triangles, consider triangle APB and triangle CPD. To prove they are similar, it should obey either of the three properties, three postulates we have studied, SAS, AA or SSS. Here, these two angles will be equal. These two lines, these diagonals, when they cross each other, these two angles are the vertically opposite angles and they should be equal. So, we can write angle APB is equal to angle CPD. And the reason is vertically opposite angles. Okay. So, we got one angle from these two triangles equal. Now, when I consider these two parallel lines, AB is parallel to DC. Okay. Consider this line BD. BD is passing through AB and DC. Yes. BD is a line passing through AB and DC, which means BD is a transversal. When a transversal passes through a pair of parallel lines, what happens? We have corresponding angles equal, alternate interior angles equal. Now, these two angles are alternate interior angle. Okay. See, this is a Z shape. Here, AB is parallel to DC and this BD is a transversal, which means these two angles should be equal. Angle ABP equal to angle CDP. They are alternate interior angles. Alternate interior angles. Similarly, when you take this transversal, AC is another transversal. When AC pass this part, these two angles will be equal. They are also alternate interior angles. But this is not actually necessary. We have got two angles. So, using AA postulate, we have triangle APB, similar triangle CPD. So, first part is clear. We have proved these two triangles are similar. Now, the second part of question, we have to show that PA into PD is equal to PB into PC. Just take the corresponding side, the ratio of the corresponding sides. Here we have triangle APB, similar triangle CPD. Then the ratio of their corresponding sides will be equal. So, corresponding to AP, we have CP. This is AP and this is CP. AP by CP is equal to PB by PD. PB and the corresponding side is PD. This is PB and this is PD. One more, AB and CD. AB by CD. Okay. Here we have PA, PD, PB, PC. Okay. So, we actually can neglect this part. We don't need this. We only need this part. AP is PA, CP is PC and that is equal to PB by PD. Okay. Now, cross multiplying, we get PA into PD is equal to PB into PC. PA into PD is equal to PB into PC. This is what we have to show. Got it? Problem number 3, question 4 of exercise 15A. In quadrilateral ABCD, the diagonals AC and BD intersect each other at point O. If AO is equal to 2 times CO and BO is equal to 2 times DO, show that triangle AOB is similar to triangle COD and the second OA into OD is equal to OB into OC. Let us consider a quadrilateral. This is a quadrilateral. Quadrilateral is a figure with 4 sides. I am naming A, B, C, D. These are my diagonals AC and BD. They intersect at a point O. We have to show in the first question, this AOB triangle and COD triangle are similar. What else is given? We have AO is equal to 2 times CO and BO is equal to 2 times DO. Okay. From this part, I can write AO by CO is equal to 2 by 1. Yes, taking the CO to the opposite side, it comes to the denominator, and to complete the ratio, I am putting 1 here. Similarly, BO by DO will be equal to 2 by 1. Okay. This is my first equation and this is my second equation. When I compare these two equations, we have right hand side equal and the left hand side different, which means left hand side also should be equal since their right hand side are equal. That is AO by CO will be equal to BO by DO. Okay. AO by CO is equal to BO by DO. Now, these are the corresponding ratio of corresponding sides of triangle. Yes, when you consider these two triangles, these are the parts of the sides of triangles. Okay. Now, we also have for these two triangles, AC and BD are two lines which intersect at point O. Then these angles are equal. They are known as vertically opposite angle. Angle AOB is equal to angle COD, that is vertically opposite angles. Vertically opposite angles are equal. Then what we got? We have the ratio of corresponding sides equal. Okay, when you consider this AOB angle, we have AO and BO. AO and BO. Similarly, for this COD angle, one part of COD angle, to the right part we have CO and to the left part we have DO. Okay, that is by using the SAS rule or the SAS postulate, we can say that triangle AOB similar triangle COD. Okay, got it? We have vertically opposite angles equal. Then what else? We have this AO, ratio of AO by OC equal to ratio of BO by OD. Okay. So this is how we can show that these two triangles are similar. Now second part we have to prove OA into OD equal to OB into OC. What to do? We have ratio of corresponding sides of the similar triangles equal. So here we have AO corresponding to that CO. Ratio of AO by CO will be equal to OB, OD. OB by OD, and that is equal to AB, CD. AB by CD. Okay. Here we need OA, OD, OB, OC. That is, this AB by CD can be neglected. Only this part. Okay. Cross multiplying here, we get OA into OD is equal to OB into OC. AO and OA are same. So this is also proved. Just the idea, corresponding side, the ratio of the corresponding sides of similar triangles are equal. Okay. First, in the first part we have solved, we have proved that these two triangles are similar. Here we have the next problem, problem 4, question 6 of exercise 15A. In triangle ABC, BM perpendicular to AC and CN perpendicular to AB. Show that AB by AC is equal to BM by CN is equal to AM by AN. Let us take a triangle ABC. This is the required triangle ABC. What else is given? BM perpendicular to AC. From B, I am going to draw a perpendicular. Perpendicular means it should meet this line AC at an angle of 90 degree. So this is the required BM. From the vertex B to the opposite side AC, I am drawing a perpendicular. When you draw a perpendicular, angle will be 90 degree. Similarly, we have CN perpendicular to AB. From vertex C to the opposite side AB at N, angle 90 degree. We have to show that AB by AC. This is AB, this is AC. Then BM by CN. BM. BM, CN, AM by AN. AM, AN. Okay. When you consider these sides, we get two different triangles. Yes, we have to consider two triangles. Consider triangle AB, BM, AM. AB, BM, AM. These are sides of this triangle ABM. Okay. Consider triangle ABM and triangle ACCN, ACCN, triangle ACN. If we are able to prove these two triangles are similar, then their corresponding sides will also be, the ratio of their corresponding sides will be equal. So we can prove this. Let us start. So when you consider these two triangles, we have a common angle. This A is common to both these triangles. Therefore, we can write angle BAM. From triangle BAM, we have angle BAM equal to angle CAN of triangle ACN. CAN. What is the reason? This angle is common to both the triangles. Common angle. What else? Here, when you take ACN, this angle is 90 degree. Yes. And when you take ABM, triangle ABM, this angle is 90 degree. Okay. Therefore, angle ANC and AMB are equal. Angle ANC equal to angle AMB. Both are 90 degree. Okay. So, we got two angles equal using the AA postulate. Using the AA postulate, we have proved that triangle ABM similar to triangle ACN. Okay. Triangle ABM similar to triangle ACN. Now, we can take the corresponding ratio of the corresponding sides. When you take triangle ABM and ACN, AB, the corresponding side for AB from this triangle ACN is AC. Therefore, AB by AC. Yes. Here we have AB, here we have AC. These two sides. Then, BM, CN. Here we have the BM and this is CN, the perpendiculars. Equal to BM by CN. Equal to. Next, AM and AN. Here we have AM and here we have AN. They are in ratio, that is AM by AM. Okay, this is what we needed to prove, and this is because corresponding sides of similar triangle. Corresponding sides of similar triangles. We are taking the ratio of the corresponding sides of similar triangles. Hence, we can prove this. Simple, right? Just we had to prove these two triangles are similar. After proving they are similar, we just need to conclude that corresponding sides, the ratio of the corresponding sides will be equal. Next, problem 5, question 10 of exercise 15A. Angle BAC of triangle ABC is obtuse and AB is equal to AC. P is a point in BC such that PC is equal to 12 cm, PQ and PR are perpendicular to sides AB and AC respectively. If PQ is equal to 15 cm and PR is equal to 9 cm, find the length of PB. We need to find the length of PB. First, let's consider the triangle ABC with BAC being an obtuse angle. Okay. So, this is BAC and a required triangle is ABC with angle BAC being an obtuse angle. AB should be equal to AC. This is AB and this is AC. Given they are equal. Okay. P is a point in BC such that PC is equal to 12 cm. I am considering a point P here and given PC is equal to this part is equal to 12 cm. PQ and PR are perpendicular to sides AB and AC. PQ. From P to AB, I am drawing a perpendicular. So this angle is 90 degree and this point is Q. Okay. Similarly, from here, starting from P, a perpendicular is drawn to AC. So this is the required perpendicular and the angle here is 90 degree. Point is R. We have drawn the perpendicular to sides AB and AC respectively. PQ is given, which is 15 centimeter. PQ is 15 centimeter and PR is 9 centimeter. We need to find the length of A. We need to find the length of PB. This is PB. We have to find the length of PB. Okay. Let us consider the required two triangles. Consider triangle. We have PC given, PR, PQ, and we need to find PB. For that, we can consider these two triangles. Yes, triangle PBQ and triangle PCR. PBQ and triangle PCR. We have taken these two triangles. Now, let us find what can be done to get these two triangles similar. If they are similar, we'll be having the corresponding sides. Yes, the ratio of corresponding sides will be equal. From that, we can find the value of PB. First, we have to prove they are similar. How can we prove this, that they are similar? Here, we have studied a property. Angles opposite to equal sides are equal. Here, it is given that AB is equal to AC. Since AB is equal to AC, angle PBQ will be equal to angle PCR. And the reason is angles opposite to equal sides are equal. Okay. Here when you take the angle opposite to AB, will be getting angle PCR. Yes, and angle opposite to AC will be getting PBQ. Okay, so we got one angle. Now to get the second angle. If we get the second angle, we can use the AA property. Which is the second angle? Here we have drawn perpendiculars. When perpendiculars are drawn, we will be getting the 90 degree angle. Therefore, PQB and PRC are equal. They are equal to 90 degree. Angle PQB equal to angle PRC. They are 90 degree. Now, using the AA postulate, according to the AA postulate, we get triangle PBQ similar to triangle PCR. When we get two triangles are similar, then the ratio of their corresponding sides are equal. That is PB, PC are the corresponding sides. PB from triangle PBQ and PC from triangle PCR. PB by PC equal to BQ by CR equal to PQ PR. Okay. What are the non-quantities? We have PC. What is PC? We have PC, which is 12 centimeter. Then we have PQ. Here we have PQ, which is 15 centimeter. And we have PR. We need to find PB. Okay. So we can remove this part and take PB by PC equal to PQ by PR. Now put the values. We need to find PB. PB by PC is 12 is equal to PQ. PQ is 15 centimeter. 15 divided by PR is 9. Then what is PB? PB will be equal to 15 into 12 divided by 9. Cancelling. Here we get 3 and here we get 5. 3 into 5 is 15. 3 into 3 is 9. Again cancelling. 3 4s are 12. So the answer is 20 centimeter. Okay. The length of this side PB is 20 centimeter. Got it? First step is we have to prove that these two triangles are similar. After we prove they are similar, just take the corresponding side ratios. Okay. Next, problem number 6. Question 13 of exercise 15A. D is a point on the side BC of a triangle ABC such that the angle ADC is equal to angle BAC. Prove that CA square is equal to CB into CD. Let us consider a triangle ABC. Okay, D is a point on the side BC of triangle ABC. So here we have a point D and I am joining this. It is given that angle ADC is equal to angle BAC. ADC, this is point D. So this angle ADC is equal to angle BAC. This angle. Okay. We need to prove CA square is equal to CB into CD. So here we have to consider two triangles such that AC is a part. Here we have AC. Here also we have AC. So AC should be a part of the triangles considered. Okay. Then which are the triangles? We can take this triangle ABC and triangle ADC. Okay. Now it is given that these two angles are equal. Yes. So this A should come in the middle and this D should come in the middle when we consider the triangles. So BAC, triangle BAC. Consider triangle BAC and triangle ADC. ADC. Okay. Here how can you show that they are similar? We have angle BAC equal to angle ADC. First thing, okay, angle BAC equal to angle ADC, which is given. What else? Here we have taken 1. What else? Is there any common angle? Yes. This angle C, that is ACB of the first triangle and ACD of the second triangle are equal. Angle ACB is equal to angle ACD. Common angle. Now using the AA postulate, we have triangle BAC similar to triangle ADC. Okay, we got two similar triangles. Now take the corresponding parts ratio or the corresponding side ratio. Here BA by AD first equal to AC and DC. AC, this is AC and this is DC. AC by DC. And that is equal to BC. This is BC, AC. This is AC. BC by AC. Now we need to prove that CA square. So we need CA. Yes. So here we have AC. Here also we have AC. What else? We need CB and CD. Here we have CD. Here we have BC. That is, remove this part. CA by CD is equal to CB by CA. Just I am rearranging it. AC and CA are the same. Okay. Now cross multiplying. What do we get? CA into CA is equal to CB into CD. That is, CA square is equal to CB into CD. This is the required proof. Hence proved. So here first we are taking the similar triangles. We are showing these two triangles are similar. Important thing, you have to consider the side AC. AC should be common to both the triangles. Then we are taking the corresponding corresponding sides of similar triangle ratio. Okay, from which we are removing this part because we need only CAs and CB, CD. So removing this part, on rearranging this, that is cross multiplying, we get CA square is equal to CB into CD. So this is the required proof. Clear? Next problem, problem 7, question 18 of exercise 15A. In triangle PQR, angle Q is equal to 90 degree and QM is perpendicular to PR. Prove that. First question, PQ square is equal to PM into PR. Second, QR square is equal to PR into MR. And the third, PQ square plus QR square is equal to PR square. So first, let us consider the triangle. Triangle PQR such that angle Q is 90 degree. So this is the required triangle PQR. We have the Q angle 90 degree. QM is perpendicular to PR. From Q, I am drawing a perpendicular to PR. This angle is 90 degree. Okay. We have the point M here. We have to prove first one, PQ square is equal to PM into PR. We need side PQ, PM and PR. PQ, PM and PR. Okay. So this triangle should be chosen such that PQ is common to both the triangles. Only then we will be getting PQ square. We need PQ 2 times. PQ should be common to both the triangles. What else is needed? PM is needed and PR is needed. So we will take the two triangles PMQ and PQR. Consider triangle PMQ and triangle PQR. Understood why we have taken these two triangles? PQ should be common, 1 point, because only then PQ will be coming 2 times. Then we will be getting PQ square. What else? PM should be a part of one triangle, PR should be a part of other triangle. That is why we have taken these two triangles. Now, we have to show these two triangles are similar. Is there anything common to both these triangles? We know side PQ is common. Similarly, we have this angle P. Angle P is common to both the triangles. Yes. Therefore, we can write angle QPM is equal to angle RPQ. What is the reason? Common angle. Okay. Next, we need one more angle to show the AA postulate. Yes. Here we have a 90 degree angle PQR. Angle PQR is equal to, here again we have a 90 degree PMQ. Angle PMQ, 90 degree. Okay. So using the AA postulate, we have proved that triangle PMQ similar to triangle PQR. Okay, similarity is proved. Next, we will be taking the ratio of the corresponding sides. PM, corresponding to PM, we have PQ. PM by PQ is equal to MQ, QR. MQ by QR, and that is equal to PQ by PR. PQ by PR. Now check the sides. What are the sides we need? We need PQ 2 times. Here we have a PQ. Here we have a PQ. Okay. Then we need PM and PR. Here we have PM and this is PR. So we are neglecting this part and we are taking these two sides, required sides. That is PM by PQ is equal to PQ by PR. Next step, the same procedures we have done in the previous question. Cross multiplication. Taking this here, bringing this here. We get PM into PR is equal to PQ into PQ. Yes, that is PM into PR is equal to PQ square, or PQ square is equal to PM into PR. This is what we needed to prove. Hence proved. Second, we have to show QR square is equal to PR into MR. We need QR, side QR. Here we have QR. Then PR and MR. PR. This is PR. This is MR. Now, this side QR should be common to both the triangles. So, we will consider triangle RQM and RQP or RMQ because here we have 90 degree. RMQ and RQP. Consider triangle RMQ and triangle RQP. When you consider these two triangles, there is a common angle. Yes, this angle R is common to both the triangles. That is angle MRQ is equal to angle QRP. MRQ, QRP. This is a common angle. Okay, we got the first angles common. Next, 90 degree angles. Here we have RMQ and RQP. Both these angles are equal because they are equal to 90 degree. Angle RMQ is equal to angle RQP 90 degree. So, using the AA postulate, we get triangle RMQ similar to triangle RQP. Okay, we have shown these two triangles are similar. Next what? Yes, taking the ratio of the corresponding sides. RM and RQ are the corresponding sides. RM by RQ ratio will be equal to then MQ, QP. MQ by QP and that is equal to RQ, RP. RQ by RP. Okay. Now check the sides. We need QR. Here we have RQ, that is QR. Then here again we have RQ, QR. Okay. We need PR. This is PR. RP is PR. Then we need MR. Here we have RM. So neglecting this part, we get MR by QR is equal to QR by PR. Okay. Next step, cross multiplying. We get MR into PR is equal to QR into QR. MR into PR is equal to QR square. QR into QR is QR square. That is QR square is equal to MR into PR. This is what we had to prove. Hence proved. So this is the second part. Now the third part, we have to show PQ square plus QR square is equal to PR square. From the first question, we have shown that PQ square is equal to PM into PR. Let us take this as equation 1. Okay. From the second, we have shown QR square is equal to PR into MR. This is our equation 2. To get the third part, what we need to do is, I am going to add these two equations. Equation 1 plus equation 2. What do we get? Left hand side. Left hand side, here we have PQ square from the first equation plus QR square from the second equation. That is equal to PM into PR plus PR into MR. Now here we have PR common. We can take this PR outside. Left hand side, PQ square plus QR square is equal to PR into. What is remaining? Here we have a PM plus here we have an MR. PM plus MR. We need to show PQ square plus QR square. Left hand side is okay. it should be equal to PR square. How to get PR? We have one PR here. What is PM plus MR? This is PM. This is MR. PM plus MR will be equal to PR. Yes. Therefore, we get PR into PR. PM plus MR is equal to PR. That is PQ square plus QR square. Okay. So, we got PQ square plus QR square is equal to PR into PR. That is PQ square plus QR square is equal to PR into PR is PR square. This is the required proof. Hence, proved. Okay. So, the first and second we are doing separately. After which, just adding the first and second equations, we get this PQ square plus QR square is equal to PR square. Only logic that we have used is taking common PR. After taking PR common, the remaining things when you add, you get the side PR. PM plus MR is equal to PR. Okay. That's all for today. In today's class, we have discussed about similar figures and congruent figures. We have studied about the corresponding sides and what corresponding angles are. We have also discussed the three important postulates, SAS, SSS and AA postulate for proving similarities. Hope you all enjoyed this session. We have also solved many questions from exercise 15A. There are a few more questions which you can solve on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.